Welcome Algebra 2. We're jumping in this week at lesson 56 through 59 in our Algebra 2, okay? Now, one thing I want to point out to you is Saxon does a great job incorporating the geometry and the Algebra 2 together. So in lesson 56, it talks about angles and proofs, and we'll go over those concepts very quickly, but I will not quiz or test you guys over a lot of these concepts simply because we have a separate class that we focus in on the geometry. So your textbook focuses in on circles, minor arcs, and major arcs, and we've talked about those even with our last couple of lessons as we've been looking at polar coordinates and rectangular coordinates and all those things. So a major arc is more than 180 degrees. Minor arc is less than 180 degrees. And I do want to point out to you those terminology, like all those terms in boldface. It would be good to take time to just look over those, especially this week as you have a little bit of extra time to look over those. Now, don't forget, and we'll study this in our geometry Saxon curriculum as well, but on page 241, it shows you an inscribed angle. And don't forget that inscribed angle is half whatever arc is intercepted. So you can see there the actual central angle is the same as the arc, 60 and 60. I'm on the bottom of page 241. And then A would be 30 degrees simply because it's inscribed. So they've done the picture for that there for us to kind of understand that. So that way you guys can see how important that is. And that's on the bottom of page 241, just to kind of see those differences there. So I want to point that out. Again, that's page 241, okay? Don't forget, a chord just touches the outside of the circle, but a secant actually goes all the way through it. It's a line. Tangent just touches the circle in one place. Now on page 242, they've shown you some different things that are, that are important to remember. Remember that when two lines intersect, the opposite sides. I'm sorry, Sadie desperately wants to be a part of Algebra 2 today. All right, so the book is actually teaching you there that if there are two angles that intersect, then add the two exterior arcs and then divide it by 2, and that's what x will be. So both of those are 60 degrees. So again, that's on page 242. Now, another thing it shows you is if it's an exterior one. So does everybody see? I'm looking for the first one we did here, and we added those two arcs and divided by 2, and that's the interior. But over here, because this is an exterior angle, then you take 80 minus 40, and that is 40 divided by 2, and that exterior angle would be 20. So those are a lot of fun things, and again, you'll do these in geometry, so don't let that overwhelm you or intimidate you. It's just some really neat concepts there. So they even show you when you've got two sides that are tangent, you're going to take the major arc minus the other angle that's formed, which is 100, and you end up with that angle of x is 80. So I'm in the middle part of page 242. So there's a lot of neat geometry that's formed, but I just want to point those out to you. It does talk to you about proofs and about how to set those up. So let's take a look at page 243. So A is the same. They just turned the circle. A is the same as page 242. Oh no, I thought it was the same. I'm sorry. It's so close. A is so close. It's just a frog's hair smidgen difference. I know frogs don't have hairs, but it's a great little saying, isn't it? So how do I solve what letter A is? Well, I add the two together. So it'd be 80 and 60 make 140. So 140 divided by 2, x would be 70. Do you see that? That's practice A. Now, practice B, because it's on the exterior, we subtract them. 80 minus 60 is 20, and then 20 divided by 2 would be 10. So that is letter B. So your book is just kind of going over those and just asking your help in solving those. So like letter D, 280 minus 80 would be 200, and then half of 200 would be 100. So X for letter D is 100. All right. So not a whole lot of new concepts there, but it is important nonetheless just to kind of go over those. Some of you may be scheduled to take the ACT this year as a practice. So I definitely think it's important to take that time and, just go over those. Letter C was the only one we skipped on our practice on page 243. And again, that one would just be 70 minus 20 is 50. Take half of 50 is 25. So we did all of our practice on lesson 56, okay? Let's jump on to lesson 57, ideal gas logs. So that begins on page 245. Now, if you're scheduled to take some kind of chemistry class, you're probably going to do a little bit more of this in that type of class in high school, right? All right, so lesson 57, it shows you the general ideal gas law equation. So PV over T. So pressure, and then your volume. V stands for volume and T stands for time. So your book kind of just sets those up for you. And then it shows you other ways that the law can be used. P over T equals P over T for the second time, right? So it also tells you the units that should be in. And I know right now you guys are thinking, yeah, is this really important? But especially in chemistry class, sometimes they can change around those units, and that's going to make a big difference. So temperature is always in kelvins. So that's really important. And notice down at the bottom of page 245, it's all in boldface. However, we must always be careful to use the same units throughout a particular problem. So super important. The problems will be worded so that the units will not need to be considered. We will just use the numbers. So in this textbook, they're assuming that you guys understand that all the units are the same, but in your chemistry class, they may not be. So be on the lookout for that. All right. So your book gave us 3 example problems, and I think that is super important as we're setting those up to solve those ourselves. Now let's, and I would encourage you just to take time to read over those examples and make sure you're familiar with those. All right, so let's look at practice A. It says 8 liters of an ideal gas at a temperature of 1,000 kelvins had a pressure of 200 newtons per square meter. If the volume were increased to 10 liters and the temperature reduced to 800, what would the pressure be? So we're just using that formula and we're solving it. So let's just take a moment and go to our board and solve that. All right. So we're looking, again, this is lesson 57, and we're looking at practice A. So don't forget, it's the pressure times the volume of the first, and that's being divided by the temperature of the first. All of that equals pressure of the second, volume of the second over temperature of the second. All right. So we're just saying all of this equals all of this, the first and the second. So let's just plug in what it gave us, right? It gave us that the first had a pressure of 200 and the volume was 8 liters is what it said. And the kelvins, the temperature it gave us was 1,000, right? Now, it wanted to know what the pressure of the second was. We don't know. But we do know they increased the volume to 10 liters, but they reduced the temperature to 800 kelvins, right? All right, now all we have to do is reduce that. Now this would be, I can actually just mark these 2 out. So it end up being 8 times 2 is 16. And then 16 over 10, so that would be 1.6, right? 16 over 10 equals, now the book actually just cross multiplies, equals 10 pressure of the second divided by 800. Now I can cross multiply and then divide by 10. So you're just kind of solving this. So the cross multiplication equals 10. So 10p2 equals, I can move that over 2 places. So that's going to be 168 times 8. So 10, 8 times this would be 48. I'm not using my calculator. You guys can tell I moved my calculator around, so I'm missing that, aren't I? 8, 12. So it ends up being that, but then I'm going to divide through by 10. So my final answer, if I divide through by 10, that's going to mark that out. So the pressure of the second is going to be 128. And don't forget that pressure is in newtons per meter squared. All right, and that's what units it told us it was in at the very beginning, because we remember temperature was in kelvins and the volume was in liters. All right, so that's all that I do is I just set it up according to my formula and then just solve for the unknown. So in this case, all of my numbers were on this side. I just reduced, and then here I just was getting that pressure by itself. All right, and one thing you could have done right from the start is just cross multiply. I could have just said 1,000 times 100 and then this times this and solved. So whichever way you find it easiest, just to get that unknown by itself. So that's all you're doing. Now there's one more problem, but I'm not going to take time to do that just because I feel like you're going to do this more in chemistry class. But again, it's just taking this formula and setting it up. So on letter B, the temperature remains the same, so you actually don't even have to put the T there. So it's just P and V of the first equals P and V of the second, because since the temperature remains the same. So you're just looking for the pressure of the second again in the part B, whereas you did the same in the first one. All right. So that everybody is lesson 57, and again you'll see that more in your chemistry class, hopefully in high school. Now, lesson 58 is our third lesson that we're covering this week. And I love that Saxon really teaches you the nitty-gritty of completing the squares. Now, I will tell you personally, I never encourage a student to complete the square unless two things are present. The first thing is that the leading coefficient should always be 1. And then the second is the middle term should be even, because that makes completing the square much easier. Now, Saxon teaches you to complete the square with both of those. And I'm very proud of the hard work that you guys have done with that. But I prefer, because I've seen a lot of students make mistakes with that, I just prefer to use the quadratic formula. So if the leading coefficient is not 1, and if the middle term is not even, then I just go straight to the quadratic formula. Now, your textbook, starting on page 249 and 250, teaches you how to do that. So you are more than welcome. Your book has the final answer and shows you how to do those. But instead, I'm going to take the time to just show you how to use the quadratic formula, because I think that's the easiest way to solve those. And I'm not teaching you to be lazy. I'm just teaching you to use your tools effectively, right? Because, in our tool belt, when we approach a quadratic formula, we need to ask ourselves, can I factor it? That's always the first thing I do. If I can factor it, I love factoring. So I try to factor first. If I can't factor, then I ask myself, is the leading coefficient 1? Is the middle term even? If those things are present, then I will complete the square. If I can't say yes to either of those, then I go straight to the quadratic formula. So some students don't like completing the square at all, and some of them just do one, either factor or quadratic formula, and that's perfectly fine. All right. Another thing is you can always graph them and see where they intersect. All right. So let's jump into lesson 58. And again, your book is showing you how to complete the square. And remember that as long as and this is of a quadratic. So all it's asking us is where does it cross the x-axis? So it's here and here. So that's what factoring or completing the square or using the quadratic formula, that's what it solves for. Have you ever done something in algebra and you think, I got an answer, but I have no clue what this answer even means? Well, that's why as a teacher, I think it's important that you guys know what you're solving for, right? So letter A says 3x squared plus 5x minus 6 equals 0. Now, right from the start, I would ask myself, can I factor it? And I don't think it can be because I don't think it can be. I tried to think of the factors of 6. Now, you might find it, but I did not see it right from the start. But my leading coefficient is not 1, and this middle term is not even. Now, the book does teach you how to complete the square, but you're going to have huge fractions that you have to square. So I think it's much easier to use our quadratic formula. A equals 3, B equals 5, and C equals -6. Now remember my quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. I'm sorry for all the squeaky board sounds, but so all I have to do now is just plug away. I call that plug and chug, right? So negative b would be -5 plus or minus the square root of 5 squared minus 4 times 3 times -6. Don't forget that square root symbol goes all the way, and then 2 times 3. So it's going to be -5 plus or minus the square root of 25 plus minus and a minus together. So it's going to be 12 times 6 is 72. And then over 6. So -5 plus or minus, that would end up being 97, the square root of 97 over 6. All right, now let me look at my answer key and see what they came up with. So this is lesson 59. Lesson 59, practice. Oh, no, this is 58. I'm sorry. I'm one lesson ahead. Can you guys tell? So if I'm able to bring this in, the book did it this way. I'm not sure if you guys are able to see that clearly, but it took them this long, and what they ended up doing is their final answer was -5/6 plus or minus the square root of 97 over 6. We got the exact same answer, exact. But my answer, and you could have just grabbed your calculator and just typed those in, but they had quite a bit where they had to take 5/3 and then square that. So they had to add 25 over 36 to both sides to complete the square. And you're welcome to do that at home, but I just love my quadratic formula. I'm a big formula person. So if you tell me what that formula is and I can just plug it in, I love it. So I think that's, again, much, much easier. Now, again, everybody's mind works differently. So if you prefer to use completing the square, you are welcome to. Now, there's a practice B. And that practice B is a little bit different formula. Let me write that one up there as well. Practice B is 3x squared. 3x squared minus x minus 1. All right, so same thing I can do there. And it's going to be negative b, which would be a -1. So it would be +1 plus or minus the square root of, that would be 1 minus 4 times 3 times -1 over 2 times 3. So I end up with 1 plus or minus the square root of 1 plus 12 over 6. So my final answer is going to be 1 plus or minus the square root of 13 over 6. Now the book shows you to separate that 6 out. So it's 1 over 6 plus or minus the square root of 13 over 6. And if you take a look in my answer key, look how many fractions they made here. So there's tons and tons of fractions, but you'll notice the exact same answer. And they completed the square using lots of fractions. And instead, my friends, we used the quadratic formula and just took a couple of steps. So I'm saying all that to encourage you, do what you're comfortable with, all right? I like completing the square, but my favorite is factoring or quadratic formula. Those are my go-to, and that's what I feel confident in. Do you know, we tend to be more confident in what we use more often. So I would encourage you guys to keep on plugging away with those and keep on giving it your best. All right, the last lesson that we're covering this week is lesson 59, and it's all about experimental data and making sure you've got a line best fit. So you want to make sure that your line is an equal number above it and below it. And then there are some equations that have fractions and decimals. You just want to write equivalent equations there and make sure that you're solving them. Then they also have a little bit of rectangular form to polar form. So we're just going back and forth to convert those. So this time they've given us the rectangular and asked us to convert it to polar, but before they were giving us polar and asking us to convert it to polar. Okay, now letter A is an experimental data problem. And so it says the data looks like this. It says write the equation that gives nitrogen as a function. So you're just kind of looking there for what's my slope and what's my my y-intercept. So all you're going to do there is find 2 points to try to figure out. Now, one of them goes through a point, and then you're going to have to guesstimate another point. And I would probably guesstimate, it looks so close to that fluorine in grams. It looks like 30 and 50. So I would use those 2 points to try to figure out what my slope is and to solve those. So you've done that before, is just try to find the equation of that line. All right, the issue there is you don't have 2 points, so you're going to have to make a second point. All right, letter B, it has fractions and decimals. So on letter B, lesson 59, you want to convert and rewrite it so that you can use those. So like let me go ahead and put that on my board. All right. So one of them has a fraction, one of them has a decimal. So what I want to do is just write new equations just because they're very difficult to work with. So the first equation that they gave me is x over 3 plus 2y over 7 equals -3/7. Well, that's an ugly fraction. Well, what if I just multiply everything by 21? Well, I'm going to end up with 7x plus 7 goes in 3 times. So that's going to be 6y. 7 goes in 3 times. So it's going to be -9. So what I did is I just rewrote an equivalent equation getting rid of my fractions. Does everybody see where that came from? And then they gave me another equation, and the equation had up to 2 decimal points. So it's 0.01x minus 0.6y equals 3.03. Well, if I move everything and I multiply everything by 100, I end up with 1x minus 60y. I had to move it over 2 equals 303. So now I've got all of this. Now I can solve it one of 2 ways. I could multiply this one by -7 and then eliminate, or I could isolate this x and I can substitute it in. So either one of those is a valid way to be able to solve that. Okay? I'm not going to take the time to do that just because I know that you guys have used substitution and elimination. All right, and then letter C is just going backwards with the rectangular coordinates. So they said -3r and -5 up. So we know that if I'm looking on a graph and it says it went -3 to the right, that means that it went back 3. And then it said -5 up. So 1, 2, 3, 4, 5. So the point is here. Okay. So what we're supposed to do is find out what that would be written as a degree and what this distance would be, right? So we're again going to have to use the angles and all those things to be able to solve it. So I could say, what distance is it from here? And I know that this is 3, and I know that this is 5. So I can find out using the sign. I can use a squared plus b squared equals c squared and find that. So it'd be 3 squared plus 5 squared, right? Because that was 3 and that was 5. So, and then solve that equals c squared and then square root it. So that's going to be the distance, the direction of that. And then I've just got to find out this would be 180. And then I've got to find this angle. So in order to do that, I could just say the tangent of x is opposite over adjacent. So opposite would be 5, adjacent would be 3. So then I could find out what that angle was based on it, okay? So then once I figure all that out, then I'm going to add that to 180. So that way I'll know the exact amount of degrees. And then I'll also know the distance of this using the Pythagorean theorem. All right. So that's all of our lessons this week. And I hope you guys have a great week.